So my presentation tonight is on dynamic GraphQL with Go. So first, I just want to give a big thanks to Google Developer Space for hosting the event. And also, if you're not already a member of our groups, we've got a meetup group, a Telegram group, a Facebook group, and others. So by the way, if anybody says anything, I'm not going to hear it because I have like a delayed echo in my headphones. Sorry. All right, cool. So basically, if you're not aware of what GoJakarta is, GoJakarta is a monthly meetup focused on the Go programming language, but we also incorporate other topics related to Go, such as deploying Go apps on the cloud. So we're always looking for presenters, so please contact me or Winda. This is our contact info. I think it's also shared maybe in the video description or some such, or if not, just join our groups and we're there. The next meetup, we're going to be doing something with GraphQL and Go Singapore maybe later this month. We'll share the details when that's available. Real quick, my company Broncos is hiring, so for all kind of technical positions, just solution architects, engineering managers, back end, front end, site reliability engineers, etc. So if you're technical or technically oriented, please send your CV. Careers at Broncos. These slides are available online. Just do a go get -u gophers.id/slides. All right, so just want to get into it. So if you're not aware of what GraphQL is, it's a query language that is designed, quote unquote, for your API. That's the silly description from the GraphQL.org website. It was initially built by Facebook in 2015, and it basically allows clients to dynamically build and send queries in a way that's meant to be forwards and backwards compatible and independent of the client's needs to format, model, or present the retrieved data. GraphQL is designed so that it kind of solves the problems of both mobile and web apps, and you'll see why that is in the syntax in the next couple slides. But what's really great about it is that it really reduces, possibly eliminates the round trips to backend, so you can kind of get all of your data in one single request. So when you're dealing with mobile apps and you're dealing with, latency that's introduced from mobile networks, this is where GraphQL can be very useful. What's really good though is it really allows development teams to move faster because it creates a highly decoupled front end from the back end. Typically, if you've ever done some very heavy UI intensive applications, basically what it has to happen is that when a new feature or something needs to get introduced, there has to be some implementation done by the back end. What it allows, though, what GraphQL can allow or enable, at least when used properly in a development organization, is to essentially be able to send queries or build queries in a client and not have to have any knowledge of how that backend is or how you connect to it or any of that kind of interesting information. So just to give you an overview, this is what GraphQL looks like. So this is a simple GraphQL schema. This is taken directly from the GraphQL homepage. What you can see here is that you've got you have a type declaration. If you notice, the syntax here is very similar to Go, which is one of the reasons why I kind of like GraphQL. I'm not exactly a big user of it, but I can appreciate its utility for certain situations, even if my company or my development doesn't necessarily intersect with it. But you basically have, your field names, you've got a type, and then, you've got, for example, here, contributors. This would basically be an array or this specifically, it's a JavaScript array because the responses actually come back as JSON formatted data. So it's a JSON array, right? The reason for that the data comes back formatted in JSON is so that it's easily consumable by web clients or in web applications. So given that very simple schema, and there are a lot of other extensions to schemas. You can declare separate queries, you can declare mutations, you have interfaces, you have a whole wide variety of kind of modern things that you don't find in other syntax languages like SQL or others, that allow you to basically create very composable graph queries in a way like this. And ultimately what it kind of comes down to is you end up building a query that looks like the above box, which is you basically query the actual field or the name. You have a parameter. In this one, it happens to be name. That was declared back here. It's basically declared by your type. So you can essentially query, typically in a GraphQL query, you can query any of the fields. And unlike, let's say, SQL, which has a lot of different types, GraphQL really only has a few built-in types. So string, integer, ID, and a few others, which are, and basically objects. Because there's really trying to be a one-to-one mapping to JSON. So you're essentially limited to the types that you have inside of JSON, which are objects, arrays, strings, and then numbers, which is really all that JSON has. And that's really kind of what you point out here, is that you query for the fields, possibly the subfields, and then that comes back to you in the query. And you get this one-to-one mapping in the JSON response, which is shown here between, for example, project, tagline, etc. And then this is in your graph query, i.e. what's here on the above. For the way it works is that it essentially traverses a graph store, or at least something that represents a graph store or can be represented as a graph store. And you traverse the edges essentially until you get to your end nodes. And then the end nodes are the values that are returned for that. So for example, in this, you have an edge named project in your type, which is the project type, right? And then you're essentially then traversing and asking for the tagline. When it has a terminating node, then it returns that data, that set of data, which is here that a query language for APIs. This just give you a very simple example of how this works. Now, this is not too fundamentally different from, let's say, REST or other RPC mechanisms such as gRPC, etc. It's just different. And I really want to emphasize that there isn't really a lot that there isn't necessarily one way versus the other, i.e. using REST or using this. And in fact, if you go back to the kind of the history around GraphQL, Facebook originally built it to facilitate greater, graph style queries on existing REST-based APIs. So they can coexist and live in the same world. What really it does is it kind of decouples the direct, let's say, socket by which, and I don't mean TCP/IP socket, I just mean like a socket in the abstract tool sense of where the query is actually created. In previous kind of models, your servers would be responsible for managing all of the queries and that you can actually execute against your data store, if that's a SQL database or if it's a graph database or whatever it is. What GraphQL does is it front loads that behavior in a consumable, easily digestible query language onto the front end, and then basically then enables the web apps to rapidly build queries and process responses without really requiring additional overhead or burden, and being essentially hyper optimized and efficient. And one of the nice ways is that because it just can be transmitted over any kind of mechanism, including binary protocols or HTTP or whatever you may want. It's not tied, for example, to a specific server implementation like SQL might be. So, for example, you could build queries inside a web client, or you could build queries inside a mobile app and send that query via a REST API or send it via gRPC to the backend. It's really just up to you. So anyways, there are 4 major freely available maintained packages that allow you to manipulate or deal with GraphQL and Go. I'm only going to cover the top one, which I think is probably maybe the most idiomatic and clean API. I'm not really necessarily concerned about selecting things based on performance. Honestly, I haven't really evaluated the packages for any kind of large scale performance, so I couldn't make a recommendation on one or the other. But what I find, the top one here, this Gophers GraphQL Go, I really find that its API is the most idiomatic and probably the cleanest out of all the APIs. It's a little rough around the edges, but at least it's something that's usable, and that's the one that I'm going to focus on showing how to use it to build some dynamic applications. So here is a sample of using this package. I stole this directly from their example. Basically, what we are going to do is build a very simple server and test it. So given a GraphQL schema, which is here, this is basically defines the type query. The way GraphQL works, by the way, is that the top level type named query with a capital Q inside this schema actually becomes the primary query or entry point for that schema. So if there are no other types or things defined, that is the only type. And what we're basically doing here is we're defining a just essentially one edge hello that returns essentially the final endpoint of a string. Sorry, end node, not endpoint. And what we're doing here is we're just parsing the schema using our package. We're using an HTTP handler, and there's a nice built-in package called relay in the GraphQL package that basically allows you to expose this and use it just as a standard query endpoint that will plug directly into Facebook's relay, which enables, for example, using GraphQL directly in React or React Native applications or other JavaScript frameworks that use that. Going back to the query, the way that the package works is that it just uses Go reflection, but it does it in a fairly optimized way because it does it at essentially quote unquote compile time, or it does it at runtime, but it quote unquote compiles the endpoint. So it's not like it has to continually look up the value of this. So it's a one-time operation on the reflection to determine the endpoint. It maps, because of the rules of reflection in Go, requires that it needs to be an exported method. The names in the schema, which is, for example, here, need to map essentially to an uppercase one. So that is a little confusing if you're not used to it, but if you're a pretty experienced Go programmer, you can basically run it, you can basically catch on pretty quickly on the mapping rules on how this works. So basically then, just going back through real quick how this works is we're just creating a handler that's handling /query. and then we're just basically starting that using the default HTTP server implementation in Go. By the way, all of this code is already on GitHub. You can get the slides and basically build it and run it, which I'm doing here. Typically, I would do a real-time demonstration of this, but I have a lot of material to get through still, so I just take my word for it that all of the code that I'm showing here tonight builds and runs, and this is the actual output here. So you would execute this using just standard HTTP. This relay handler really all it does is it's just part of the GraphQL package, the Gophers GraphQL package that I'm using, and it just does it in a nice simple way to build an HTTP handler for you. However, as I mentioned before, the GraphQL, while it typically is used or accessed through HTTP endpoints, there is no reason why you have to do it. You could build a gRPC server and also build a handler around that and expose it as a gRPC service or anything else that you want. This is just nice because it shows you very quickly what the output would be, which is essentially this JSON data, which is this is the format of it. So you would have a data hello hello, and then this is the end node of that graph on what that value is. Okay. All right. So why is this useful? So in something like 15 lines of code, you've got a very, very quick implementation that will be able to solve or answer dynamic queries. It'll plug directly into Facebook Relay, React, React Native, any kind of JavaScript stuff. And it really just allows you to just move very, very quickly if that's the what your organization or you are trying to do as a developer. And what's really useful for this about using GraphQL in general is that it really allows front-end teams to kind of explore and experiment without requiring, significant changes on the back end. And for me as a back-end systems developer, I'm very lazy. I don't want to do any work. And if I can somehow enable my front-end teams to, go off and explore without, bothering me, then, all the better for me, I suppose. All right. So I'm now going to go through the more complicated social example that's included in Gophers. The GraphQL Gophers package. This is the right out of the box. It works. It's kind of gives you a high-level overview of how a large organization like Facebook would use it. I'm just going to go through it very quickly to really just kind of showcase the features of the GraphQL language and how they would be used with this package in Go. All right. Is this visible? Yeah. I'm going to move that off the screen so it's a little easier. Okay. Okay. So it's a standard Go program. They have the schema here that's listed. And this is what I was referring to earlier about having a lot more features inside the GraphQL language itself. So this schema definition here basically allows you to define the top level query. There are two primary definitions on schema. This is kind of a special meta or annotation, I suppose, inside the language that just essentially shows the entry point. But you basically any type of query can be exposed directly. It doesn't have to be defined this way. They're just doing this to basically showcase how that's done. Now, basically what this is this type query is entering three types that are here, essentially admin, user, and search. that are basically can be queried at the same time. And these have parameters that are passed to that. And this here is after the colon, that's basically the return type that query would return. So an admin returns an admin, a user query returns a user, a search query returns a search result. Interface here basically shows you it's a generic shared interface. It's very similar to interfaces in Go, but much like in Java or other kind of object-oriented language, you have to basically declare a type that implements that interface. Now, what the Gophers GraphQL package does is it basically will allow you then on that query to return that value, different types that basically have that, and it will translate that into the client or marshal that into the response in the correct way that the client will be able to understand. If you're assuming that you have some experience with object-oriented programming or you understand interfaces in Go, this is probably pretty self-explanatory on how that works. They are declaring the scalar time. Inside this package, they have a special time type that marshals values back and forth between the standard Go time values, and you have to basically declare your own time type that then allows you to use it. But then you can use the actual package type, and I'll show that in just a bit. That basically allows you to use and marshal times in your queries or in your GraphQL schemas. All right, so this is pretty self-explanatory. You have a type. The thing here that you might not be aware of here is on the pagination. This is an input. This basically is listed here as a what do you call it? An optional input into this parameter that will allow you to page through it. It's declared this way. They've just declared it pagination. This allows you to basically reuse it as a type or a parameter, so more like a parameter type that's used for all of your various queries. But that's what the point of that is. There's also some very basic stuff like enums. Those are similar to kind of constants in Go or in, let's say, maybe a SQL database where you declare enums. And then union search result. If you're not familiar with unions, this really comes from basically the C or C++ or maybe some other kind of programming languages that you may not be familiar with. But it basically is saying that a search result is exactly the same as a user. In Go, this would be something like a type alias, but they're using the moniker union because I believe you're actually able to union multiple types in the GraphQL, schema declarations. Okay. All right. So to go through that, you can see how there's a direct correlation. So for example, on that admin, let me show you side by side. On the admin implementation, so the interface here, admin, was declared. Notice they've declared admin here as the same interface, the equivalent in Go. This ID type is a special scalar type that is built into the GraphQL language, and they have a corresponding direct type, package type that's declared as .id. Similarly, the time type would be user declared the same. Notice here that ID, so right here, this ID here, let me just highlight that right here. Are mapped the same way. That ID maps to this. So This is one of the reasons why I had mentioned I like this package more than others, is that it's actually idiomatic. So it correctly cases certain acronyms. So for example, ID, or you know, as or let's say if you had TCP or something like that, or some other acronym or some other short name, it would correctly case it in the right way that's idiomatic inside of Go, so that your interface here would match correctly. Again, we see the same issue, that the exported name needs to be correctly cased, and that's how it would work. So similarly, basically, you have a search result, and then basically the way you do this is that you have these special to functions that converts the result to the user. Where that's used, for example, is here inside the union on the search result, so that wherever a search result is returned in a query, for example, here on the search query here, the package itself will handle the marshaling or conversion of that user to the search result, since they share the same interface. Okay. The rest is relatively straightforward, not anything different. It's just using fields. You've got a contact, a user, and again, all of those various values are returned in that same way. But here's where we get to the meat of the issue, which is the resolver. I just want to show you how this is done. How you would declare this is that a resolver gets declared on, so for example, on friends is a field on user that was declared in the schema. The resolver here basically takes the param. It does this anonymous type declaration basically on all of the resolvers on implementing it, or a resolver is just basically how your queries actually get data from your backend store to the GraphQL package, which then converts it or marshals it, I should say. But anyways, because all of the parameters are optional, they always have this kind of format. They use this anonymous type args, which is a struct, which then has the various fields declared in the order. And that basically allows you to maintain type safety even within your Go code, even if the query itself is highly dynamic. So you basically check for its existence if it's not nil, i.e., or if that's first, like i.e. if the parameter is actually first, that allows you to dynamically build the query based on that kind of dynamic information. This example is fairly complicated, so I'm going to go through it pretty quickly. I have another example that I wrote myself that gives kind of a much better idea of how to do that, but I possibly have too much content for the evening. Okay, then kind of the rest of the information inside of this in this var, this user's var. This is just essentially their data store. In a real application, you of course wouldn't have it statically declared like this. You would just retrieve this from a database or some such. They're just doing this because it's an example. It's a contrived example, and hence why it doesn't necessarily work. Now we see basically how the admin resolver works. You basically get the role field and the admin stuff. So basically you can't basically convert it to that admin unless it's not that. One of the other reasons why I also like this package, even though I haven't been using it much, is that it is fully context enabled. Context, if you're not familiar with it, is kind of the accepted or idiomatic way to handle context cancellation and propagate context or query context or whatever, however you want to phrase that, between various boundaries or API boundaries inside Go, whether you're talking about internal API boundaries inside your application or between servers or something else. It's the way to do it. So these resolvers are pretty straightforward. They just pull the information from that statically declared users map or var. I mean static in the fact that it's built into the source code and not static in the runtime sense. Anyways, here on search, again, you have a search result, and this is basically filtering out the number of users based on that information. So that's just a real quick overview of this social example. This package has some really great examples, including the quote-unquote classic Star Wars example of how to do some more complex flows. All right, so let me go back to my presentation so I can move on here. Okay, so what I really like about this package that the other packages don't seem to have is the ability to parse these schemas and then use those schemas and manipulate them in ways very similar to the Go Reflect package. Now, they call this introspection. I'm not sure if they're adopting that from the kind of the standard GraphQL nomenclature or if they're using that from some other ways. I mean, that is kind of the general term to inspect in a a query or whatever. But whatever, I kind of would have liked it if they I don't know, call it like intro reflect or something silly like that. But you can only ask for so much. All right. Anyways, so what I'm going to be doing in this next example is I'm going to take an arbitrary schema, and then I'm going to generate an arbitrary database schema from that dynamically, and that's kind of what you can do with the introspection. And I'm going to build up to that and show you how you get to that. So again, I just have I'm declaring scalar time here so that I can use it in my schema later. I'm just declaring a user that is a member of an organization. So an org is just basically a set of orgs, and then you've got kind of the standard fields: ID, email, name. I selectively chose to set some of them as required or not required. The exclamation means that it's required, just so I could give you a better example of how that plays out in the actual source code. And then here, of course, is our top level query. Basically all it is just a query for users. Notice that everything is required, meaning that you can't return or that your system won't return null data. So basically what I really want to show here is just how the introspection works and how simple it is. So you essentially just parse the schema. You don't actually need to specify a resolver as was done in the previous examples. But basically what you now can do is you can now loop over your parse schema types, and then you can display information about that schema. So the name, the kind, basically all of the information that the GraphQL parser was able to take from that system. And if you run that against the actual schema that I have here, you get something like this information, which shows you all of the declared types. So you can see right off the bat, there are some types that we didn't declare, but they're basically the standard JSON types: Boolean, float, int, things of that nature, until you get to here, where you get to the actual types that was declared in the schema itself, which is the org, the query, and the user. These others are kind of built-in ones that are part of the GraphQL specification, but I'm not really going to get into how those are used or what they're useful for. But what I really like here as well is that your actual query, you can get the same information about the query in the exact same way that you can about the types that have been declared. In fact, it is just a type, and it's just the query type, which is very useful, especially from a pragmatic fashion when you're trying to do dynamic code generation or things of that nature. If you're familiar at all with my XO package, I do a lot of SQL introspection and things like that. So what I'm going to do right now is I'm going to kind of do a real lame mix and match between essentially what my XO package does with, i.e. what using this introspection to actually dynamically generate the systems from, sorry, the queries from that, sorry, the SQL queries from that. And I'll show you how that plays together. It's a very contrived example, again, as all of these examples always are, but I'm hoping to really kind of more inspire people on what's possible and not necessarily, you know, well, let's just put it in silly terms. It's left as an exercise for the reader. All right. Okay, dynamic tables. So again, this is basically the same exact schema that you saw before. The only difference now is that I'm adding a parameter to basically filter out users, as well as an orgs query that allows you to filter the orgs by the name. And I'll show you basically how that comes back and what it is. Okay. So all of this code is actually in the repository. I am just getting down to the very minimal part. So I took the introspection code that was over here. Oops. I took this introspection code here and I blew it out into basically creating dynamic SQL queries to actually generate a table. So what you see here in the most insecure way to create SQL ever is to basically do a format.sprintf, creating a table based on the name that was retrieved from the inspected schema. And then basically I am getting the SQL type from that field and then essentially adding it as a column type. And then I'm actually then executing that against a SQLite database just for purposes of fun. I'll show you real quick what that output looks like. The generated SQL basically comes like this. And if you're familiar with SQL, it ends up being like this. Now, what I'm showing very simply is that this is, you are defining your SQL schema, not using SQL, but instead translating it from GraphQL or a very simple GraphQL schema into a SQL schema. This is obviously not usable, but with enough hard work and polishing, you could actually make this usable, which I've done, but not in this code base. Okay, and then this basically shows you how you would possibly work with dynamic queries. Similarly, similar to the social example on how the orgs query, or the other people queries on that social network, very simple social network implementation was defined. I am doing the same kind of resolver handler. I define it on a shared server type that collects all of the information, such as a database or whatever it might be. and then basically dynamically generating a SQL statement to retrieve that information from a database. Again, the way I'm generating this SQL is in the most insecure fashion possible. Do not do this unless you really know what you're doing and or you just don't care about the security or integrity of your databases. But again, just doing this as a quick example. So I'm dynamically building the SQL query itself, executing it, appending arguments, and then here executing it against the database, and then copying the resulting rows into an array, sorry, not an array, and a slice of orgs, which is the expected return value, and voila, you have dynamically built queries based on a GraphQL schema that is simultaneously creating a schema for your database and then generating the SQL to query against it. Now, this is actually something that is very similar to, I believe, a package in Python that I've not used, but I'm aware of. It's called Join Monster, I believe. So if somebody wanted to, be clever and run that, you could do it. So here's the actual tested system. I do want to show this one more than anything else. Oops. All right. 1 second. This is the one live demo that I will do. So go build. So cat intro.go. Just oops. So this is a significantly larger implementation than the others, but I just wanted to show you that it is real code. Build -o SQLite.go. All right, so it created the requisite tables in there. The fact that it is still alive and didn't die means that it's running. Now, if I copy and paste my curl statement and execute that against the system, it should give me the same exact result, which is actually running and processing against the SQLite database. Now, just to prove that, all right, so you can couple this and use those introspections and things of that nature to basically dynamically generate anything, including running mutations and modifying tables or whatever you want. So the sky is the limit here on what you could do, especially if you start coupling with this with the dynamic properties of Go. So for example, if you're not aware, in Go, basically everything in the runtime can be dynamically generated, meaning types, values, anything, a function. You can dynamically define a function completely in runtime using the reflect package. So you could write extremely fast, efficient resolvers that are basically parsed in from your schema, your GraphQL schema, that then queries against a combination of data stores such as Redis or a SQL database, or somebody was asking about streams, etc. earlier, and that's basically possible for anyone. And that's essentially my presentation for the evening tonight. I really didn't want to go over too much more because it's just so much information to cover. And but I'm really hoping I can encourage people to kind of go out there, learn more about how they can use GraphQL and Go. And I want to show that these technologies, even if they're originating in, let's say, the JavaScript world, they're just as usable, if not more usable, in the Go world as they are in a web browser or anywhere else for that matter.
My rule of thumb is to use GraphQL only for read or write operations, REST for monoliths with complex business flows, and RPCs for domain-driven microservices. But would you give a different suggestion?
Sure. I mean, REST is a type of RPC, so I'm not really sure what you're driving at here. So GraphQL is a fully featured language. You can use it to do RPC instead of REST. I'm not really saying that GraphQL is better than REST. It's just different, and it might work better for your use case. I don't wake up and decide, hey, this new service, I'm going to build it in GraphQL. I mean, I would reach for gRPC or REST first. It really has nothing to do with monoliths, has nothing to do with your complex business flows. It's just a way to execute a query against the server. So that query, I didn't really get into it, but GraphQL has things like mutations. So if you were using REST, such as doing on a post or a put operation, which, and I don't really know why RPCs would be quote unquote different. I mean, RPCs are a general concept, right? Anyways, you can do read-write operations using any three of that, using RPCs, GraphQL, REST, whatever. Different suggestion, whatever works for your company.
Also talking about decoupling, does it require a strict decoupling between server logic and client logic to use GraphQL?
Well, I mean, that's what GraphQL does. It enables the decoupling, right? So it becomes this intermediate language that the client speaks over some kind of communication protocol, possibly a REST API, possibly some other RPC mechanism, and then the server can translate that, query into whatever backend it is. Maybe you have a complex microservices based, storage backend for where data is split across 17 different systems. But what it does is it enables the decoupling. It doesn't require a strict decoupling.
Also, I heard that network caching is hard when using GraphQL since we cannot caching it based on the URL. Are the only option that we have is to do it on the server by hashing the query?
You're really referring to some kind of specific environment that I'm not really aware of or how it's configured. So caching could be more difficult with GraphQL for sure, because if you were using some kind of intermediate thing such as Cloudflare, or you were using some other CDN, sure, it may not be cached as easily via that proxy or that third-party service in the same way that a REST GET would be. But you can definitely do caching on the server side so that you don't have to continually to hit your database. There are a number of ways to do that. Hashing the query, yes, is one. But I would probably put an intermediate layer. This kind of depends on the scale that you're working with. But typically, what I would do is that I would do everything on the server side. I wouldn't try to cache queries in a CDN or a third-party service. But what I would do is I would essentially have some kind of a caching mechanism that gets the query, sees if it's in cache. If it's not, then basically it does a round trip to the data store and then stores that in memory. And then that value would be shared across multiple servers, possibly. I've done similar things using Redis, memcached, etc. But yeah, all of that logic would have to be basically manually written in Go or some such. I mean,
When it comes with BFF, back-end for front-end pattern, how do you handle your GraphQL at scale when your GraphQL schema becomes bigger and too much query and mutation logics?
I'm not a GraphQL expert, so I don't really know. My strategy for managing that would be the same as managing any other large system. I would just essentially divide and conquer. So if you have an extremely large schema and it's too much for one server to manage or handle, then I would try to break off a chunk and deploy that to a different server, whether you're talking about the logic or some other aspect. I don't really know what BFF, backend for front-end pattern is. Never even heard that before, so I apologize.
GraphQL is really beneficial for separation. Each resolvers can be written to use another way to get data. What do you think?
Yeah, so that is one of the nice things about GraphQL is that, and specifically about the GraphQL package I showed, is that the resolvers can basically use any kind of data store or any other kind of data mechanism. So, for example, maybe you have a Redis database storing user profiles or like active user sessions, and maybe one of your resolvers retrieves from that, and then you could have another resolver return data from a conventional SQL database or something else. So it does make sense to, I guess, build a gateway out of that. But I'm not sure if you mean a gateway in some other kind of a sense. So,
do you think it's possible to translate the GraphQL query into complex SQL queries, join likes, etc.?
Yes, absolutely. As I mentioned before, I believe there's a package in Python called Join Monster that does that. I've actually been working on something for something like a hybrid between EXO and Join Monster to basically do that inside Go, but it's nowhere near ready for release.
GraphQL is cool. It can collect a lot of fields with single request. So how about security? There is user role only can accessing some fields only.
In your resolvers, you could basically have something like a resolver middleware chain, similar to HTTP middleware, that basically denies the request or returns empty data for if the user's role does not have access to certain data. But that's not, I didn't cover anything even similar to that tonight.
Is it possible to make multiple GQL servers where each handles specific domains accessible through one GQL server that can route the specific GQL server according to the requested queries or mutations?
So absolutely. I'm not sure if you're talking about just like domains as in like a, web domain, or if you're talking about just like, a domain of data. But yeah, absolutely. So one of the nice things about GraphQL, and at least about that package, uh, is that as you can divide those resolvers up, you can basically front off those requests to, or quote unquote, route them to multiple backends, right? And I assume that's what you mean by the queries or mutations. So it's, yeah, all of that logic would have to be custom written and et cetera, on the front end. But otherwise, yes, absolutely, it's possible.